Hello guys, welcome to physics laboratory again. So this again is online. Okay, again the purpose is to demonstrate or to show you how to perform experiment number 4. Experiment number 4 is about Archimedes Principle. Okay, so in this experiment we have two objectives. The first objective is to determine the density of solids using Archimedes Principle. The second one is to determine the density of liquids using a hydrometer in Archimedes Principle. So in the first experiment, or in the first part, will be determining the density of solids. Okay, for the density of solids, we'll be using two metal samples. So this one is brass, this one is copper. Okay, and then for the second one, we'll be determining the density of liquid. So in that case, we'll be using two liquid samples. This one is water, and then the other one is cola or Sprite. Okay, or 7-Up. That is 7-Up. Okay, we'll be using this setup. Okay, we have the processor again, so this is used to measure the weight of the solid, and then we have of course the GLX is it measures or it stores the volume read by the processor. We'll be needing also a beaker with water, and the metal sample. We have hydrometer. So this one is hydrometer. So hydrometer will be used to measure it will be used to measure the density of liquid. Okay, actually we have two types of hydrometer. The first one is the reading is below 1.00, and then the other one is greater than 1.00. So if the density of the liquid is greater than the density of liquid or water, we'll be using the other type, which is greater than 1.00. Okay, so let's continue. Again, this is about Archimedes Principle, and then an object immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. That principle is called the Archimedes Principle. Of course, from the word itself, Archimedes Principle was discovered by Archimedes. Okay, so according to that, whatever be the buoyant force, that is equal to the weight of the liquid displaced. So we are referring here to the liquid, not the object. Okay, so that's the amount of the liquid displaced. So that's equal to the buoyant force. So we'll be needing again this setup. Okay, we already set up this one. We have the beaker filled with water. So what we need to do is, and the GLX is set to digits. Okay, what I did is I set this to 4 decimal places just to be more accurate with the reading. So this is 4 decimal places. So we need the formula here to solve for the density of solid is simply the density of solid is equal to, so that's also written in the manual. Okay, density of solid is equal to the weight of the solid in air multiplied by the density of water, which is constant. So the density of water is 1 gram per cubic centimeter. So that is to be divided by the difference in the weight of the solid in air and the weight of the solid in water. Okay, so we'll be using water as our liquid. Okay, so to start, so I'll be measuring the density or the weight of this metal in air. So the first metal is brass. Okay, the second metal is copper. So I'll be placing here the metal sample. So here, this is brass, then we have copper. So weight in air, we need to measure the weight in air. So that is in terms of, this is in terms of dyne. Okay, this one is the weight in liquid, also in terms of dyne. This is the density of solid. This is the theoretical value of the density of solid. So we have the theoretical value, so the theoretical value can be seen at the table. Okay, we have the table for the density of, okay, we have the table of densities for aluminum, for brass casting, for copper, for iron, for lead, for steel. So these are the constant value for the density of solid. So meaning, if we have the brass, we just need to look at the brass, and then the value is 8.40 to 8.70. So if that is brass, the theoretical value is 8.40 to 8.70. Okay, that is the range for the density of brass. And then for copper, copper has a constant density of 8.94 gram per cubic centimeter. So this is 8.94 gram per cubic centimeter. So what we need to do is to compute for the experimental value of the density of brass and density of copper based on the reading on the weight in air and then weight in water. Okay, so this one is brass. So the weight in air is somewhere, so a little vibration might cause fluctuations in the reading, but I'll be using 1.3033. So 1.3033. So this one is, the weight in air is 1.3033. Okay, this is in Newton. So we need to convert that to dynes. Okay, again, 1 Newton is equivalent to 100,000 dynes. So 1.3033 multiplied by 100,000, 1.3033 multiplied by 100,000. So this is equal to 130, 330. So I just need to add another 0 here, and then I will erase the decimal point. So this is 130, 330 newtons. So 130, 330 dynes, I mean. Okay, so this is the weight of the solid in air. Now I'll be putting the solid, or I will be submerging the solid in water. Okay, now obviously there should be decrease in the weight. Okay, that is because of the buoyant force. Okay, so the reading is 1.1552. So 1.1552 times 100,000, so that's 115,520. 115,520. So this is 115,520 dynes. Okay, so the unit here is dyne. Okay, then we need to compute for the density of solid. Again, the formula for the density of solid is the weight in air multiplied by the density of water over the weight in air minus the weight in liquid. So this is the formula. Okay, so I'll be computing for that one. Okay, density of solid. So we have weight in air, 130, 330, multiplied by the density of water is 1, so multiplied by 1. So the 1 is constant, so the density of water is 1 gram per cubic centimeter. Okay, divide by the difference between the weight in air and weight in liquid. So 130, 330 minus 115,520. Okay, so the value is 8.80. Okay, the value is 8.20, 8.80. Okay, so since the closest value here is 8.70, so I'll be using the 8.70. Okay, 8.70 as the density of brass. So let's compute for the percentage error. 8.80 minus 8.70 over the theoretical value is 8.70. So the answer is multiplied by 100. Okay, the value is 1.15. So the percent error here is 1.15 degrees, 1.15%. Okay, that's for brass. Then I will be replacing this one by copper. I am done with the first sample. Now for the second sample, this is copper. Okay, for copper we have the constant value, or the theoretical density, which is 8.94 gram per cubic centimeter. Okay, the same procedure. Let's measure the mass in air and also the mass in water. Okay, so that's 1481. So 148, 100. 148, 100. Okay, I will be using this reading, 148, 100. So this is 148, 100. Again, the reading on the force sensor is 1.481. So multiplied by 100,000, so that's equivalent to 148,100. And then I will be submerging that to the water. Okay, and then again, the expectation is there should be decrease. There should be decrease in the weight. Okay, in the weight of solid in liquid. So 130.33. 130.33. This is just a coincidence that this is the weight of brass in air. 130, 330. 130, 330. Okay, And then I'll be computing for the density of solid. Again, the formula is simply this one. Okay, the weight in air. So weight in air is 148,100 multiplied by 1. Okay, which is the constant value of the density of water divided by the difference, 148,100. 148,100 minus 130, 330. Okay, then the value is 8.33. So the density, the experimental value is 8.33. I guess I have here more than 10% error. So I'll be computing for the percentage error. Okay, so that's 8.33 minus 8.94 divided by 8.94, because 8.94 is the theoretical value, times 100. Oh, this is 6.82. So the percentage error is also 6.82. Okay, so this one is 6.82%. So this is for the first part of the experiment under Archimedes Principle. Okay, thank you guys.